So, welcome Jaxx Vane Studio Live 35, working on the sailing simulator. And we're in this week where we're working mostly, well, we work only on networking and trying to push forward to having multiplayer in the game. So exactly like the last couple of streams, it's going to be a little bit boring. Not much action, but we're getting closer. Right now, yesterday I was able to actually, let me see if I can run it. I was able to get the boat to spawn in multiplayer, which is interesting and a good result. So we have the server running and we start the client. And bang, and we get our bot. We get our bot. So it's connected, it's getting the response, it's creating the boat. All fine. And then I disconnect and it understands that it needs to disconnect. Everything works fine on the TCP side. So today I started to work on the UDP. So let's see what the potential target for today should be, and it's really to set up the UDP communications. The way this works is, I went briefly over this, but let me repeat it. So the communication between the client and server is divided into two channels, and one channel is based on TCP, and that channel is basically transporting all the messages that needs to be reliable and in order, while the UDP is going to carry all the messages that the game needs to be able to deal with these messages, even if they come out of order or they don't arrive at all. These are basically the position updates. With this kind of games, when you have a complex physics system, you generally don't go in the direction of things like first-person shooters, where you get the client to the server to actually simulate the entire game, and you get into a much more unsafe scenario where the server is basically trusting the client with what the positions of the boat are. And this is sadly, it's a necessity. Is when you have a physics that is just too complex, going into a direction where you're sending just inputs is just not feasible to try to replicate the entire system. Is also an economic problem, because yes, you will basically need a server that is able to handle all these CPU load, right? To simulate the entire physics. It's something that is totally possible if your game has a simple physics, like a first-person shooter, where your player just moves at semi-constant velocity and is just reacting to collision and things like that. But if you have something complex like this or a car simulator, then it's not possible. And in the future, one thing that I'm going to try with this project is to see if there is a way for me to validate what the boats are doing by using some kind of system where you record the boat behavior in general, and try to validate what you're seeing based on that behavior that you know. So you know what is possible and what is not possible. With boats, this should be slightly easier than with cars because there are probably less elements involved. A boat, by definition, a boat is probably at least one order of magnitude simpler than a car. If you think, a boat is pretty much one single rigid body with lots of forces acting on it, and that's more forces than you get on a car. If you look, for example, at the amount of point of contacts between the boat and the sea, that's huge. In a car simulator, I don't know, in ACC, I think we're up to something like 5 points per tire. So you get collision with the environment. There's like 20 points in general. On this one, we are approaching 1,000 points. So 1,000 points that generate forces. So from that point of view, it might look that a boat is more complex, but the boat doesn't have suspension, it doesn't have tires, it doesn't have drivetrain, it doesn't have It doesn't have springs, it doesn't have dampers, it doesn't have third springs. So it's like in way more simple, as a simulation goes. So hopefully in the future, it will be possible to try to validate boat speeds on the server and catch people that are cheating. At least it should be possible to catch obvious cheating. Yeah. So if every boat is doing 8 knots and there is a guy that is going around at 14, that's easy. That's pretty easy to spot. Obviously, if the system is able to spot that guy, then you will need the hacker will get smarter and get the advantage of his hack, make the advantage of his hack smaller. So instead of going 14 knots, he will make like half knots more than everybody else. And at that point, it gets more difficult to decide, okay, this guy is really cheating or he's not cheating. But it's an interesting topic. Sadly, the reality is that dealing with cheaters is an ongoing battle, and it's usually a losing battle. The more you invest into trying to do it, the more it becomes a challenge for them to try to come and break whatever system you come up with, right? Yeah, of course. And the other possibility is to implement this kind of super invasive anti-cheats, but then you get the players complaining, right? So it's basically a battle that developers cannot win, because game developers are trying to make a game, and so right now it's like whatever direction you go, you're going to lose, right? So there is no winning in this battle. But I have to say, this is a problem that is going to be nice to have, because it is going to mean that the game already reached a level of popularity to attract hackers, which is already a victory, right? So if I ever find myself dealing with this stuff for real, then I'm already good, right? It means that this game is already doing pretty well. So nice Gibson. Yeah, thank you. I changed my guitar wall at the beginning of this week, so we got the Gibson. today. Putting hot tea on your face is asking if I'm using an external library to implement UDP. No, I'm just using the standard net UDP sockets and building up from there. So without a standard in the near future kernel, and without a standard in the near future kernel will be full of anti-cheat for each multiplayer games. Yes, that's also a problem. So you basically, the more you install these kind of games with invasive anti-cheats, the more your PC will be full of this stuff. Yes, so I can understand. I can understand gamers not liking that solution. But right now we don't have a solution. I think the only possible solution to this is the for gaming to go into the direction of Stadia, or something where you basically don't have any direct access to the game running, and that will be an instant improvement when it comes to anti-cheat. You can still cheat. You can still cheat on some controls, for example, right? If you can, I mean, you can do incredible stuff. So yeah, you imagine in a car game, you can have like some kind of system that is analyzing the audio coming out from the game and develop a traction control system based on the identifying the tires noise when the tires is losing grip, and it automatically cut the throttle, and there you go, and then you have a cheat that it will become very, very difficult to detect. Right, not impossible, but it will require a lot of work and see some kind of high frequency response in the gas control, but then the risk to start to have false positives and punish players that are doing nothing wrong becomes really big, and even worse, in my opinion, than having cheaters, right? If you start, it's a little bit like piracy, right? The moment that your anti-piracy system becomes an annoyance for the player that actually paid to play your game, then you're losing. You're losing. If you make the lives of the people that pay for your game worse than the lives of the people that didn't pay for your game, then you're already losing. So it's a similar thing with the cheating. But anyway, we're talking about, as I usually say, we're talking about step number 2000 something, and we're stuck here at step 20. So yeah, I have friends who bought games and download the pirate version because of always online stuff. Yeah. Sometimes I'm sure that there is an element of like, okay, let me find an excuse so I can justify to myself and to my friends that I'm basically downloading this pirate version of the game. I'm sure that there is an element of that it's like a little bit like people going online and desperately trying to find something to be offended about, right? So I'm sure there is something of that, but yeah, it's difficult. There is no easy solution to this stuff. Right, back to our world. So what I want to do today is to get this very simple UDP sockets coded in, and then we will set up a system to detect the ping between the server and the client. And then we get into, in my opinion, what is the most important part of the entire multiplayer system, and is how time is synced between players, the client and the server, right? That's the entire point. The entire point of multiplayer is to be able to reliably say, this guy was there at this point in time, right? And it's, as you can imagine, is a super complex, is a super complex problem, because you're dealing with an internet and you're dealing with packets that are arriving at a completely unpredictable rate, right? So when you read on a game that you have a ping of 100, that's an average ping. If you actually go to look at the actual ping registered by every single packet, it's not 100 every time. Is there is something called a jitter, right? So the time that it takes for a packet to leave your client and reach the server, and vice versa, from the server to reach your client, is a variable time. So you're dealing with this total uncertainty, right? And obviously the bigger is this time, so the higher is your ping, the higher is the jitter, right? So you're dealing with more and more potential error, right? And this is something that a lot of people that play games online are unfamiliar, and when they discover this, they get shocked. But it's the reality of thing, because what you're trying to do is, first of all, fight this jitter, and then you have the other problem. The other problem is that on a client, you are trying to predict what the position of objects, right, either player, cars, boats, what have you, what that position is going to be now at the moment I am calculating the frame based on an information that is 100 millisecond, 200 millisecond old, right? So you're constantly trying to guess where this guy is, right? And your guess can be an easy guess. So for example, if you have a first-person shooter where the player is basically moving pretty much at constant speed, right? In first-person shooter, if you start moving from 0, you might have a little bit of acceleration ramp that brings you to max speed, but then you get to the max speed and there you are. So trying to calculate okay, where is this guy? I know that this guy was in this position 200 milliseconds ago and is moving with this velocity. Where is he now? It just becomes a matter of trying to guess, is that guy still moving or not? Because if it is still moving, you know in a first-person shooter that is moving at a constant velocity, right? So it becomes easy to guess where it's going to be. The only possibility is that the player stop moving or hits a wall or whatever, and you can't guess if the player stopped moving or not. But for example, you can start to guess if, okay, is he going to hit a wall, and you can sort of do something with that and stop the person penetrating through a wall. But when you get in something like a race car, this becomes 1,000 times more difficult, because cars not only never move at constant speed, never, they don't even move at a constant acceleration. So it's like, it's the worst nightmare you can have, right? It's never constant speed, there is never constant acceleration. Cars on a racetrack are constantly changing both those values. So trying to guess where a car is based on information of 100, 200 milliseconds ago is very complex. Well, it's not complex, it's impossible. It's basically impossible. So you end up with something that I call an error So you are going to end up with an error. And then at that point, you will have to fix that error. And the sad part of this is that depending on your ping, this error, which is, you can imagine as a circle of, when you see a remote car on the screen, you can imagine in your head, okay, there is a circle around this car, and this car in reality could actually be anywhere in this circle, right? And that's the error circle that you have. So being very near to another car in a racing game online is always a danger, and it gets worse the more your combined pings get higher, right? So if you have a very good connection and you have like a ping of 20, and then you're playing with a guy that is playing from the other side of the world and is playing with a 300 ping, then you have a combined ping of 320, and your error circle gets bigger. And you can imagine that is not just, it gets the more I talk about it, the worse it gets. You can imagine that it's not just your circle, the circle that you see, that you can imagine on that car, but it's also your own circle on the remote car. So it's like they both combine, and that's why sometimes, sadly, sometimes too often, in racing games, you get collisions, and you see one car flying away, like registering a collision, and the other car that didn't. It's simply because, they weren't close enough, and, because of the error that you have, they see something slightly different, and one car saw the collision, the other car didn't see the collision. And it suddenly is not something you can solve by using the server to validate. You can use the server to validate things like damage. Like, all right, okay, this guy, because the server can know, and it's something that I'm going to do in this game, because in this game, compared to Assetto Corsa, the server, it's calculating more stuff. All the rules are going to be on the server. Just give me 1 second, sorry, and I will read your question and answer. Otherwise, I lose my train of thought. So the idea for me in this game is that things like the rules of, okay, have I passed this mark or have I not passed this mark? And especially the other main rule, which is going to be another huge challenge for this game, which is, applying the rules of sailing is going to be done on the server. So the server is going to be deciding who is right and who is wrong. And there will probably be no collisions at all in this game. So pretty much when two boats get close enough, the server will decide which one of those boats is at fault. That boat will get a penalty, and the other boat will just go, as if the other boat was not even there, right? So we'll see how that works, but that should solve a huge amount of class of problems. So you will never have a guy that has no clue about racing rules connecting to a server and destroying the race of everybody else by hitting them, right? All right, let me read what Sori is saying. Yeah, I have a friend. Okay, yes, this case where they pay the version of the game they pirate. Okay, I guess a car moving at a very high speed will be even harder to predict. That's correct. The higher the speed, the more the error gets bigger. It's actually the thing that really makes the error bigger is the acceleration. So the acceleration potential of the car. So the worst possible nightmare is a Formula One car braking at 5 Gs, right? So that's the worst thing you can have, because you have a car that is going from 300 kilometers per hour down to 80 kilometers per hour in 100 meter, right? And that's very difficult to predict and very easy to get it wrong. So that's why you often see people racing with cars that don't have a huge potential of acceleration. It doesn't matter how fast they are. So you can run with a 67 Formula One car, which does 300 kilometers per hour on the straight, but it's a car that cannot do much more than 1.2 G in any direction. So it becomes easier for the system to calculate that and to predict that. Of course, the other fact is that if you're racing with cars or boats that are slower, then you also expect to be able to get much more closer to another car. So the problem reappears again, right? So, yeah. So that's the plan for today. Let's get to it. I was already doing, this is an option. A little bit stupid there is an option, isn't it? Hopefully I don't trip that unwrap there. All right, so I should be able to just run this without any error, and we're ready to move to the server. Right, okay, so no error, we just get nothing, which is fine. So can put this one, and now right, we get this one and it's fine. We need to return the other server UDP port, because the old Stefano would have done JX in C++. I would have done this, right? Which is what you don't want to do on Rust ever. You don't want to do this. You could do it. You could go. You could totally make this code look like shit and start adding lifetimes, blah blah blah. So you could go server with a lifetime of blah blah blah, and you know, JXS server. You could totally server, right? You could totally do this, right? But then you will have to start add, okay, lifetime here, lifetime there. Forget it. I'm gonna do that. Can this run on Linux? Probably the server could. Probably the server should be able to run on Linux, yeah. Right, okay, so server. Yeah, or RefCell, of course. You really like RefCell. I don't like it. I mean, I can live with this, and the code is much cleaner like this. I don't mind. Basically, I'm trying to do the entire project without having any reference in the struct. And it's working great so far. You know, it really makes the code. This is something that I totally love about F#. One thing that I love about F# is that there is an order of definition of stuff, right? And you cannot forward declare stuff, right? So your software really becomes this, you know, top-down relationship graph, right? So you can't go up, you cannot go back up. Well, actually, you can only go up, right? So the stuff that is down can reference the stuff that is up, but the stuff that is up cannot reference stuff that is down. And so it's actually possible. You can do self-referencing stuff with the but again, you know, you're working a little bit against the language. You have to look how to do that, and it's limited. I forgot what the syntax is called right now. I think is with or something like that, where you basically write one declaration and then you say wait, boom, and you write another declaration of another thing, and they can refer to each other. Right, anyway, I wouldn't mind if Rust, you know, people say Rust is influenced by OCaml, which also has this thing, I think. But apart from the let, there isn't really that much. Yeah. Yeah, and yeah, I think it's that, it's and. Yeah, I think it's that one. It's really cool. Okay. Right, so if this works, we should be able to see this connect success message coming through. Right, so we're looking for this. Here we go. So UDP address is blah 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 3334. Yeah, baby. Yeah, baby. Run the game. All right. So let's wait for the ping. 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 I could do this all day. Right, okay, so it works. This should work. Let's see. Yep, pairing address with connection. Great. Received ping. All right, but okay, received ping. Okay, that's cool. That's cool. We're almost there. Let me just do the pong and yeah, Blinkster, you you saw it in the future. Right, let me do the pong, and I think I'm good for today. So right. Interesting, we have a ping of 2.5. Interesting. The reason why we have a ping of 2.5 is because our step in the physics, which is also the frequency at which the network system works, is 5 milliseconds. So it will take at least 5 milliseconds to go and come back from the server. So this is the minimum ping that we will ever see. 2.5 milliseconds. So everything is pretty much working. I haven't done the time sync yet, but that will require a lot of work. Is the whole game written in Rust? Yeah. Yes, I have a small C++ library that I use to do stuff that would be too annoying to do in Rust, especially if I have to interact with C++ libraries. Like for example, I have this FW1 font wrapper, which is it's a library to fonts in DirectX 11, and because it's got a C++ interface, then I can't really interact straight away from there. I also have small stuff like calling this DirectX math library. So all these extern C functions are stuff that I exposed and I can call from Rust. And also to interact with the Autodesk FBX SDK. Yeah, so a little bit of direct input stuff. Yeah, so I have some small amount of code in C++. And ping, fine with 0. Ping is going to be way more complicated than this because we need to smooth it out. We cannot use the last ping over the internet. That's going to jitter all over the place. So we will have to have a range of pings and work on the average of that range of the last pings. So and I would imagine we are already pinging. I will hope so. Looking for receive ping, boom, 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 ping, 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 ping. All right, okay. It's all working. Perfect. It's all working. We're all happy, and Team Baudet is online. So let's move to Team. I always have to remember how to do this. And Team is working on racing games. Yeah. What's wrong? And you guys, yes, I will be back. I will be back next week at on Monday, 10 o'clock as usual. And I hope next week we should be able to see boats in multiplayer. So have fun with him. Have a great weekend, and I'll see you on Monday. Ciao, ciao, ciao.